Hello everyone, welcome to the second visual experiment this semester on equilibrium. Chemical equilibrium plays an important role in our lives. According to Le Chatelier principle, if a stress is applied to a system that is at equilibrium, the system will respond by shifting in the direction that reduces the stress in order to reach a new equilibrium state. The equation that's on the board is currently at equilibrium because we drew the double arrow. For example, if you increase the reactance, that will shift your equilibrium to the right. Or if you increase the product, that will shift your reaction to the left. The reverse reaction will be more favorable. Temperature is also another key factor for an exothermic reaction or an endothermic reaction. For example, in an exothermic reaction, heat has been released as a product. If you increase the heat of the reaction, that will push your equilibrium to the left, favors the reverse reaction. So in this experiment, we're actually going to look at the effects of different stress applied to the system at equilibrium. Well, let's take a look at the first part of this experiment between chromate ion and a dichromate ion. Okay? The chromate ion is a yellow color, and we're going to react with some sort of acid, and it will produce dichromate ion and water molecules. Alright, so the chromate ion is actually from the 0.1 molar potassium chromate, and then the acid that we're going to use is sulfuric acid. Okay, so let's look at the procedure. The procedure asks us to measure out 3 milliliter of 0.1 molar K2CO4 potassium chromate. Okay, so let me do that. This is 2 milliliter. Let me get one more. Alright. Please make an observation of the potassium chromate solution. You will need to have this recorded in your data sheet. Okay? Then I'm going to start adding the acid. Okay. Make myself some room. I'm going to add sulfuric acid dropwise. So I'm just going to add a couple drops, then use a clean glass rod to mix it. Okay? So as you can see, the color of the reaction changed from yellow color to orange. Okay. Follow the procedure again. We're going to add sodium hydroxide. We know that sodium hydroxide is a base. It's clear color. Okay. Look at what happened to the color when I'm adding sodium hydroxide. And then think about, in your reaction mixture, there is an acid species, right? Now you're adding sodium hydroxide as a base. So the acid will react with the base, and then are you increasing the amount of acid in the solution, or you're decreasing that? What happened to the equilibrium? Does that shift to the left or shift to the right? So I'm just going to add a couple drops. Mix it. Add a few more drops. Mix it again. Okay. Well, you can see the change. Now we're changing the color back to yellow. Hello, let's take a look at the second equilibrium system. I'm first going to measure out 3 milliliter of acetic acid. Okay. Because the acetic acid is colorless, in order for you to visualize the result, we're going to put some indicator. Remember what the indicator is? The indicator that changes color at various pH, right? So I'm going to add indicator. This is called methyl orange. 2 to 3 drops. 1, 2, and 3. I'm going to mix it, and then you're going to record it, a color of this solution in your data sheet number 9. Okay. So this is the color. Record the color in your data sheet number 9. And then I'm going to add some sodium acetate. Okay. Sodium acetate is an ionic compound that will fully dissociate in water. Okay. So let me mix it a little bit better until all of the sodium acetate dissolve in the solution. Then we're going to make another observation of it. Okay. Please bear in mind that at the high concentration of the acid, the methyl orange is a red color. At the lower concentration of the acid, the methyl orange is more on the yellow side of the spectrum. Or it could be orange, yellowish, like this color. Okay? So record this color into your data sheet number 10. Okay? And this is the formula of sodium acetate. When this is added to water, it will completely dissociate into acetate anion and sodium titanium. Okay? Think about this. When we're adding the sodium acetate into your system at equilibrium, which species are we increasing the concentration of? And which side of the equilibrium is shifted to? Alright? So I'm going to set this aside and move on with step number 8. I'm going to measure out another 3 milliliter of the acetic acid in a new test tube. Again, I'm going to add in the indicator, methyl orange. 3 drops. Mix it. Okay. This time, instead of adding the sodium acetate, I'm going to add sodium hydroxide. Again, sodium hydroxide is a base. Remember, when you're adding a base to your reaction, the base will react with your hydronium ion, the acid, to give a water, right? So you're actually decreasing of the amount of hydronium ion in your system. And then think about where the equilibrium going to shift. Okay? So sodium hydroxide. Where's my sodium hydroxide? Alright, here's the sodium hydroxide. I'm going to add 1 drop of sodium hydroxide first, and then I'm going to start adding drop-wise. Okay? Well, this is really red. Okay? So, 1. Mix it a little bit. Just add another few. Mix a little bit more. Okay. Keep going. Now you can see there's already a color change, right? Before it was on the red side, now it's more like on the orange. Okay? Yeah. So record these observations in your line 11 on the data sheet. Okay? These equilibrium system outlined on the board for you. When we dissolve cobalt chloride in water, it will actually going to form the hexaaqua cobalt 2 ion. That's in pink color, which is I have in this little bowl. Okay. According to procedure, I'm first going to measure out 3 milliliter of this. This is step number 12 in your procedure. Okay. Again, this is the pink color of the hexaaqua cobalt 2 ions. Okay. Record the color of this in line 17 of your data sheet. I'm going to add 1 drop of the concentrated HCl to the system. The HCl, when it dissolves in water, it will generate H plus and Cl minus. So basically, we're increasing the Cl minus in the system. Okay, just 1 drop, I believe. Oh, and continue adding until you see a change. Okay, just going to add a couple. Makes it a little bit. Still pretty much the same. I'm going to add a few more drops. Okay. Even before I finish this little demo, you should expect to see what color. That's really strong. Okay. Some of you may start to see the color change. It's not as purple, or it's not as pink in the before. It's more like on the purple side, right? What happens if I keep adding? Is going towards the blue color, right? If you compare them, this is called the pink, and then this is the blue. Okay. All right. Record this into your line 18 of the data sheet. And then to this system, I'm going to add distilled water. Okay, the distilled water is on the left hand side. Basically, I'm adding more reactant to this system, and then you're going to observe a change. I'm probably starting to use the glass rod. As you can see, the color is gradually flipping back to pink. Right? Just going to add a little bit more. Alright, now is more on the pinkish side. Okay, so that's that. Record this observation into your data sheet number 19. Hi, let's take a look at the last equilibrium system here. I am at step number 17 in your procedure. I have already about 3 milliliter of the saturated ammonium chloride. The saturated solution meaning that this solution will not dissolve any additional ammonium chloride solid. Okay, that's why it's called saturated. So I'm going to add 1 drop of a concentrated HCl to the test tube while stirring and continue adding more until I see a change. Okay. Let me go get my well, actually I really don't need to have anything. Not sure if you guys can see it well. There are some solids precipitated out of the solution. If the solution becomes cloudy, and then you can start to see there's white precipitate out of the solution. The solution was at saturation point. So by adding HCl to the solution, we're adding more of the chloride ions, right? That will shift the equilibrium. I'll leave this question for you. Therefore, that precipitated out of the ammonium chloride salt as it settled down to the bottom. Okay? So record this into your data sheet number 25. Okay, now I'm moving on with number 19. Use a test tube holder, place the test tube and its content, including the stir rod, into a boiling water for 3 minutes. So I'm going to put this in a boiling water bath for 3 minutes. Let me take a look. It's currently at about 90 degrees. It's not yet boiling, but it will reach the boiling point pretty soon. So let's give a few minutes. Okay. So let's take a look of what's going on here. Where is the precipitate? This precipitate dissolved, right? So you have nothing, just a clear solution. Please record these observations in your data sheet number 26. And then moving on. So this one's done. I'm going to use a second clean test tubes. Alright, I'm going to measure out a small amount of ammonium chloride salt to cover the bottom of the second test tubes. Just like this. I'm going to add some water to it, and then I want to feel the temperature change, whether it's released heat or a absorbed heat. Okay? Obviously, you're probably not able to tell this from a camera, but I'll tell you whether it feels hot or cold. Okay. So mix it a little bit. Let it dissolve so it feels cold. Therefore, this is a endothermic reaction or exothermic reaction. So record this into line 27 in your data sheet and answer the question of number 28, endothermic or exothermic. It feels cold. Okay? Alright, so that's it for this equilibrium experiment. If you have any more questions, please consult with your lab instructor. Thank you.